SwayamPrabha. Digital India. Educated India.
Welcome back. So we are in week 5. Okay. Yeah. So next week, 11th will be March 11th is the quiz. So all that will be known to you. Okay. So in due course of time, we will tell you the procedure and all that. So we'll release the question paper 5 minutes or 10 minutes in advance on WhatsApp and email. Then we'll set up a link. That link will ask your name, roll number, the number of pages, and so on. Upload it. So just write on A4 sheets of paper with name and roll number on every sheet, and then scan it. Cam scanner, Adobe scanner, whatever scanner you have. Scan it and don't take pictures of this thing. Just try to put it into a PDF and then assemble it and send it off. That's all. Okay. So if there is an internet issue, blah blah blah, whatever, you can go to the nearest place and you can write anywhere. Okay. You can go to your aunt's house, friend's house, whatever. All right. But copying is very difficult. You will come to know when you face the quiz. No? All right. Okay. Now, so please keep this in mind. And so towards the end of April, third week or fourth week of April, we'll have the second quiz, because Professor S. Balaji will start teaching from April 12th. That's the plan. So I think we would like to have it at the quiz at least 2 weeks after he starts, so that we can add some of his questions in the quiz too. And then the end sum will be a whole day affair. 9 to 11 and up to 12 o'clock upload. Then 1:30 to 2:30 part B will be neural network. Upload up to 3:30. Okay, so we'll have it in the regular D slot of the institute. So we'll complete this. Don't worry. No need to go to Kendriya Vidyalaya and all that. Okay, so we'll finish. I will release the grades in time. Okay, let's get back to this. So let's consider a linear regression. Okay, linear least squares. So the first assignment you submitted, we thought it is pointless to give you back the solution. The Maruti Service Center and all that. You can talk to Sushruth if you want. So his solution, I don't know whether he has already released the solution. So that will carry some weightage. And between first quiz and second quiz, we'll have one of the regular classes. We'll have a assignment test. So it will be set for 30 minutes. Because you're continuously having classes, we'll set it for 30 minutes and give 20 minutes for upload. Okay. So maybe on a particular Monday or something, right? So whatever you're solving in the class, I'll ask you to do it on a nice sheet of paper and send it to us. So that one plus this Maruti, that will carry some 2-3 marks. This one will carry some 7-8 marks. So we'll have this as 10. Quiz 2 and quiz 2 will be 20-20 and end sum will be 50. Is it okay? So I will give at least 1 week notice for that class test. All right. I hope everybody is able to take. If the class test somebody is not able to take because of internet issues, they have to tell us. And then we will give maybe one day or so, and they can submit the assignment later. Okay, that we will see how that works out. But hopefully now it's 1 year into the COVID, and I think the internet issue has been largely sorted out. Okay, even schools are having online classes and all that. All right, so we should not be quoting the same reason as internet. I think we should move forward. Okay, and in our case, I'm not asking you to put the camera and this thing, and okay. You can also go anywhere. You can go to a nearby internet cafe or this thing or anywhere. Take your notes, take your calculator, sit from anywhere under the banyan tree also, finish the exam and submit. That's it. All right. So linear least squares using so the linear regression actually turns out to be A sigma xi square plus B sigma xi equal to sigma xi yi. Okay. Then what is the second equation? A sigma xi plus n, bn. Okay, these were the regression equations. Okay, so let z be. Let z be let z be a matrix. Okay, it's a n by 2 matrix. Please note that we are doing linear regression y equal to ax plus b. Okay, I'll erase this. Now a is the vector of the parameters to be retrieved, or the parameters of the regression, and y is basically the data vector. So this is the data vector. Vector of the data. What data? Measurement. So you can say measurement vector or data vector. That's what that is a terminology used in the parlance of inverse heat transfer. Okay, data vector. Okay, now we can do some math on this. Let's work out z transpose t z. Okay, let's work this out. Z transpose t z. Yeah, anybody? How many are there? 80 people. Oh, I'm flattered. Even in a regular class, in IIT physical classes, 100 students in the class, and 70 people will come. Yeah, what is this now? Correct? This is correct?
Yes, sir. Yes.
Oh, very good. Now, Z transpose is Z operating on A is nothing but this operating on okay. Ah, what is the mistake I made?
Sir, we
No.
like additions. It will be a 2 by 1 matrix.
Correct. Yeah, yeah. Ah, yeah. So I'm good. 2 by 2 by 2 by 1. So all right. Now Z transpose T, blah blah blah, that is okay. And then Z transpose T operating on Y. correct? X1, Y1, X2, Y2, X3, Y3, blah, 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 over X sigma, Xi, Ya. Then Y1 plus Y2 plus Y3, sigma, Ya. Done. So you got the answer. What did you get? Therefore, huh? What was that? Sigma, Xi, Ya. Yeah, I did it.
A sigma xi square, sir.
Correct. Okay. So therefore, the linear least square can be written in terms of matrix like this. Z transpose is Z operating on this. It's fine. That's it. Okay. So you can use whatever tools you have with you to solve. And there's no need that it has to be just ax plus b. You can extend it further also. All right. So once you have the Z transpose T, then you can have A is nothing but Z transpose T, Z inverse of Z transpose T Y. So you just calculate Z transpose T Y, then Z transpose T, Z inverse of that, and you multiply that. And then you can use all your matrix relations, whatever you've learned in matrix algebra, Gaussian elimination, Gauss-Jordan elimination, Gauss-Seidel method, Jacobi iteration, whatever you want. Upper decomposition, lower decomposition, Cholesky decomposition, whatever you have, whatever tools you have with you, you can. So this is the crucial link between matrix algebra and linear least square. Please note that originally Legendary said that we should minimize the least square. The difference between the line and whatever, difference between the true value and the measurement and the most likely, and he never used the most likely because he didn't know probability. Then he enters Gauss, who said that there is a probability with finding each of these points. And if you put a regression and you have to find out the maximum likelihood probability, which is a joint probability density, which is a product of P1, P2, P3, which is L. The product is pi of pi of pi, where pi is the individual probability. So Gauss came and said, found out the crucial link between statistics and probability. Now this is linked to the theory of matrices or linear algebra. Therefore, from statistics to probability, we have come down to linear algebra. All these things are encompassed. So if you have data, now you can play with data and you can use linear matrix algebra to proceed further. So this is only for linear least squares. Therefore, if there is a particular form of the regression which is not linear but it is non-linear, it should be possible to figure out expressions for non-linear least squares, which we will be doing in due course of time. So this is the idea that least squares can be used, okay, in a matrix framework. All right. Now use this and let's try to solve the problem. Yeah. What will be the problem number? Huh? Huh?
6.
Problem 6. Consider the following data. So this is a very fresh example. I just did it at 10:30 in the morning. But I don't like to use the same example again and again. Okay. So I also did the solution on Excel, but that is on my computer, not on this laptop. But we can do this again. There should be no problem. Okay. 4.8. Okay. Consider the data consider the data. Okay, I'll give you 1 minute. I'll stop talking. Just copy down the data.
You missed a point.
Huh?
After 4, directly 6.5.
Yeah. So 5 we did not measure. Okay.
Okay.
We just gave up on 5. Yeah. Once, if you're done, just put a hand raise so that I know. Akula, dear all, please enter the attendance. Okay, very good. Okay. Akula is doing his job. Okay. All right. Thank you. Now, using the theory of linear least squares, get the best estimates of A and B. Get the best estimates of A and B if y is assumed to be equal to ax plus b, or y takes a linear form ax plus b. You write appropriately the English. Get the best estimates of A and B. Okay. Report. So the standard error of the estimate standard error equal to sigma I equal to 1 to n yi minus y fit I whole square by n minus 2 for a linear least square. Okay. N minus 2 will be 3. Why are we getting n minus 2? This doubt was raised by somebody else in an earlier class. If there are only 2 points, there can be no error. There's no point in defining a standard error because a line will pass 3 points. If you put the third point, then the error is generated because of the third point. So therefore, n minus 2 is bliss. N minus 2, you can never hope to get a standard error. Therefore, in order to tell you that the actual degrees of freedom with which you play so that you can get different lines is actually n minus 2 and not n, though n is the original number of points. So n minus 2 is the circumference of the playground with which you can play cricket. Okay, it is not n, it is n minus 2. That is why that n minus 2 comes in the denominator. And it is a standard error. Once it is a standard error, it has to be within a root. And then sigma whole square divided by n minus 2. That standard error is some sort of a imaginative error which is spread out. So this is please note, this is the standard error of the estimate of y. That means if you use this correlation and substitute the value of x, if you substitute the value of x and get the values of a and b and substitute, you will get a value of y. The error in that y, not the error in the a or the error in the b. X anyway has no error. It is not the error in the a or the error in b. The error in a and b also can be found out, but that's a different story. This is the error in the estimate. I am interested only in y. I don't really care about a and b. A and b is something which came along. It is not in my fundamental journey. Is it okay? A and b is a construct. I'm using a construct y equal to ax plus b. What I want is give me the value of x, I'll give you the value of y. Y equal to ax plus b is something, it's a mathematical construct for us to understand this world. We want to understand this linear world, in this case at least. So I couldn't care less. If there is some other way by which if you tell me x, I can give you y, I'll ditch the y equal to ax plus b. So mathematics or statistics, whatever should be used only to the extent required. If it is no longer required, we'll jettison it. All right. So I'm always interested in the error in y. Ax plus b is a form, is an avatar we have used, okay, so that it helps us do the work. It helps us do the work. The height of students in a class is a linear correlation with the age, blah, blah, blah. All that is our way of understanding the outer world. But what is the final thing? Can you predict the height? That is what. So it is this. So this is one way of doing it. It doesn't mean there is no other way of doing it. Okay. You can also do it using a neural network. You can also do it by having a probability curve. There are many ways. Okay. Often we are mistaken that because we have learned this and from high school and we already got a grade or that we know that very well, the teacher taught us this is the one and only way and this is the correct way. We often do not question, because if it is in print, if some foreign author has written a book, it has to be correct. But please question, why did all this come? Why did all this come? Is there a way of getting rid of all this? Is there a way of getting rid of calculus? We must think of those things. All right. That's what the data science people are thinking. All right, just do this. So you can do sigma. So if you do this, the transpose is that it will be very fast. Huh? Or put it in this form. You can quickly get it. Okay. Huh? It'll be easy to get it. Just if you want, you can put a tabular column x, y, x square, x, y, and so on. X square, x, y, and then y, I, y fit I. You can put a tabular column, which will help you. It should take 10 minutes. Please do it. If somebody gets that matrix, Z transpose is Z operating on this, it should be fine. So then I'll wait for that.
Sir, but here what will be the value of n? Will it be 5 or 6?
Why are you hung up on the 6? N is the number. Why? What is the problem with why 6?
No,
Why
no.
6? Who told you that I should count 1, 2, 3, 4, 5? I can take measurements wherever I want, isn't it?
Yes, sir. But like for in the second equation, we have plus bn, no? So n is the number of measurements. So we have to put 5 only, no?
Exactly. Why are you getting that doubt? It's only 5. Don't be fooled by 1, 2, 3, 4, 5, 6. I can have 1, 2, 3, 4. Next one can be 1844.
Okay, sir.
Ah. So I can take the star and inverse. Then you can use your cofactors and this thing, and already you can calculate the determinant. Be done with this. You can do it pretty fast. If you're doing, just put a hand raise so that I know that some people are working. Okay, very good. So I'll wait for 10 minutes. Don't worry, take your time because it involves a lot of things. So obviously something like this will be the quiz question. Okay, so if you're able to do it today, my courses, generally you don't have to prepare much. You can just come with the notes, and if you attended all the classes, quiz is another class, that's all. Except that whatever you're doing, I'm asking you to submit. No stress. Quiz will be the same as class. Ah, Manthan, A equal to 2.205. Huh? B equal to 2.9. Okay. Pradeep, Prajwal, all those people. So just start putting on the chat. Okay. We'll wait. Huh? Just start putting your answers in the chat. Don't worry about writer. Just start putting it. Huh? Once you have put A and B, those people who put it on the chat, go and get the R squared and the standard error of the estimate. Okay. Okay. If people have got that also, they're restless. Then try to take a sheet of paper, or if there's a graph sheet, just go around. If your sister or brother is there, who's in class 11 or class 12, just tear one graph sheet and come and plot X versus Y, or Y data minus Y data versus Y fit. I told you, parity plot. Just try to do a parity plot. Or if you have a nice, on a plain A4 sheet paper, if you have a ruler, divide the sheet into 10 parts, 10 into 10, 10 cross 10 cross. Draw a parity plot and see. This data has been deliberately given by me. Something startling will be revealed only if you plot it. If you plot it, you can understand so many things which you will not understand if you just do mathematics. What is that? What is that you will learn if you plot? Suspense. Only people who plot will understand that. Do that. Okay. I got already many people have responded. Very good. Standard error 1.6. This is Shubham 2.16, 3.08, whatever. Okay. So, how many of you still doing? Should we wait? Raise your hand if you have to wait, or you just say, sir, don't tell the answer, I'm working. Anybody? Okay. These are the people who already raised their hand. So, anybody is still working? You want us to wait? Shalu, are you there, Shalu?
Yes, sir.
You asked me something on the email. No, what was that? I forget, but yeah, I remember. Oh, workflow. Something you asked about the workflow, right?
Yes, sir. That was long back. It was sorted again.
Okay. Somebody should help me. Let's do the matrix. Anybody? Shubham. Anybody? Please help me. Tell the values of the matrix. Just come on the video.
Hello, sir.
Okay, Shubham. A11.
Yes, sir. Can you hear me?
Yeah. Go ahead. Yeah, we can. A11.
Just a minute. I'll change my virtual background.
You're having 1,000 pictures on your virtual
Yes,
background. You're a high level man. Okay. Tell me.
Yes, sir. What should I tell?
A11 I want.
A11. As in the XZ matrix, is it?
No. Z transpose T.
Z transport. Sir, Z transport
transpose T, Z, that matrix.
Yes, sir. 66, 16, 16, 5.
Is it correct?
Yes, sir.
66.
A12 is 16, A21 is 16, A22 is 5.
Very good. This one?
Z transpose Y is 191.2 and A21 is 49.8.
Very good. Okay. The inverse of this?
The inverse of Z transport Z is, so sir, I've rounded off to
okay, so what is the determinant? 330 minus 256, right?
So let me check.
330 minus 256. 44, 74, is correct?
74, yes, sir.
Then what do you do? Which one? So 5 and 66,
Yes, sir.
This is my high school math. Is it correct?
16 plus yes, sir, it's correct.
Very good. Then 191.2, 49.8.
Yeah.
Okay. Now Shubham, let's write it. Tell the answer. People can do this. How much?
So final A and B, the A matrix is 2.16 and 3.08.
Okay. All right.
Yes, sir.
So I will check one value at least. Huh?
Yeah.
So this is my calcium. 5 into 191.2 minus 16 into 49.8 equals something 159 divided by 74. Okay, so I got 2.15 and we are not bluffing. Okay, 2.15, everybody can check it. No bluff. It is truth and nothing but the truth. Okay, Shubham, stay with me now. Where is
Yes,
this
sir.
cloth? Okay, cloth is here. So equals so why fit? Please tell me.
Yes, sir. Just a minute.
Sir, 5.2,
5.2.
7.37.
7.38.
Okay.
9.53. 11.68.
15.
15.98.
Y bar. Y bar is how much?
Uh, 9.96, sir.
So this should be easy. Y minus Y bar whole square. Y minus Y fit whole square. Yeah, let's do this. 4.8, 9.96 minus 4.8 whole square. How much is this? Then we do the sigma. Tell me the individual entries. One person can tell me this. The other person, one more person can. Y minus Y bar.
Minus 5.16.
Oh, whole square.
Oh,
26.62.
Huh?
26.62.
26.6. One decimal.
Okay, 7.6. 1.3. 17.9.
Very good. Who is this?
23.4.
Azhar. Okay, 23.4. Okay, sigma Azhar.
76.99.
77. Very good. Okay, let's go to this. Hmm.
0.18.
Very good. High funda.
0.03. 0.53. 6.3. 1.4. Sigma is 8.49.
8.5.
Yeah.
So R square is original sum of the residuals is 77. Now it is brought down to 8.5 divided by 77. How much is this? Pretty high. No, not 0.9? No, less than 0.9. How much is that?
0.88.
0.88. Okay. All right. Then this is the coefficient determination. R equal to, how much is this?
Zero 0.94.
0.94. Very good. So the correlation coefficient is 94%, which is not bad. And the standard error estimate you can easily calculate now. Correct? How much is it?
1.68.
1.6?
8.
Very good. Okay, so we have solved the problem now. Is everybody through with this? This is how we solve the regression problem. Of course, we can do more. I can give you 20 data, 30 data, 100 data, whatever. After beyond a certain time, beyond a certain number of data, you may have to use Microsoft Excel and so on and handle the data. Okay. So far, so good. Okay. You can do a hand raise. Rajwal and other people, you can disable that hand raise. You can do that yourself. Okay, okay. So that I know that it's a new fresh hand raise. Okay. Now, please let me know if this you're comfortable with this. You've got the solution, right? I want some fresh hand raises now. Okay. So, is it fine? Okay, very good. Yeah. Now look at the table carefully and tell me where there is a where could be a possible problem with this. Where could be a possible problem with the problem? No, there is nothing wrong in the procedure. Everything is fine. Looks like there's some problem with the data. What is that?
Point number 4.
Who is that? Who is speaking?
Subhash.
Suhas. Yes, point number 4 is gadbad. Point number 4 is a problem. Point number 4, y is 14.2, y fit is 11, and the error is very high. Square of the error is 6.3. In fact, 80% of the standard error is brought out by this. Are you getting the point? Standard error is basically a scaled version of this 8.5. Out of the 8.5, 6.3, one fellow is contributing. So what does the data tell you? What does the data tell you?
It is an outlier.
It is an outlier, exactly. So it is an outlier. 0.4. That means no, because it is more than this, right? This is like 14.8. This is like 14. Okay, I didn't draw it properly, but doesn't matter. So this is somewhere. Array. So it is like, I hope you got the point. Okay. So forget that you're a mathematician. Now you're an engineer. What will you do now? You're an engineer. You are a smart engineer. What do you do?
We'll discard
We, we remove that data point and replace it.
Okay. Subhash, very good. Problem number 7. Remove the outlier and recorrelate. Take down. Problem number 7. Remove the outlier and recorrelate. 8 minutes. And then get the R squared and the standard error. It will be revealing. With that, we end today's class. I come again. Problem number 7. Remove the outlier. That is point number 4. Recorrelate. Work out the relation. Recorrelate the fit. Get the standard error and get the R square. Today, an important lesson will have been learned by a simple example which I constructed y equal to ax plus b. And then we designed the points in such a way that one point was an outlier. What is the theory behind outlier, blah, 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 all that we'll see tomorrow. But please note that theory, you're all hung up on theory. You can learn a lot of things through examples also, right? Examples are a great way to learn. So today's class is a proof of this. Okay, so I call it as, I've written a book on teaching also. I don't know whether you're aware. It's called The Joy of Teaching. It has sold a couple of thousands. It is in the 2nd edition now. I've just finished the 2nd edition during lockdown. So I call it as the example first approach to teaching. So this can be done in any subject. So in order to motivate or bring the attention of the students quickly, so we can first introduce the example, and through the example, we can derive the theory. It need not be done always, but you can do theory first and example later. But in order to, if there is a sagging attention in a course or in a class, there is a sagging attention, an important tool which is available with a teacher will be a well-crafted example. Okay, so it is my philosophy that if you can introduce the example first, and then as an inference, you learn the theory as an inference, this will remain in the student's mind for a long time. Anyway, this is educational theory. Forget about this theory of, this is my theory. Okay, I call it, maybe somebody else called it example first. I used it in the presentations before. In fact, tomorrow I have to give a talk for PSG college. They are arranging some program for faculty members. I'm not going there. Don't worry, no corona. It's all Zoom. So I'm just preparing that lecture with one of the TAs. So I wanted to give a lecture which will be different from my earlier lectures. So I've titled the lecture as The Power of Examples. Okay, the power of examples. And can you believe it that Maruti Service Center and Amazon Delivery Agent are becoming part of the presentation, which we solved in this course. Okay, so this will be a new presentation. So 60 or 70 slides where from different fields. Okay, we are using examples just to give you an example of, just to give an example of the example I'm giving. There's something called Nyaya Shastra. Okay, in the ancient tradition of the Indian philosophical tradition, there's something called Nyaya Shastra, Nyaya, N-Y-A-Y-A, where we try to argue the philosophical, the philosophy. So there's something called Rajju Sarpa Nyaya. Okay, Rajju means is a rope, Sarpa is a snake, Rajju Sarpa Nyaya is the snake rope analogy. So I'll just finish it in 2 minutes and let's get back to this linear square. So if there is something is appearing like a snake, it is twilight, somebody is not at 6 o'clock in the evening, it's just about to become dark, somebody doesn't know whether it's a snake or a rope. The first thing is he feels that it is a snake, then he gets terrorized. Okay, once he gets terrorized, the fear automatically overtakes him, overwhelms him. Okay, but to figure out whether it is a snake or not, what is required is a torchlight. If somebody shines a torchlight on this, he or she will know that it is not a snake, but it is a rope. Please note that a snake need not be there to cause you the fear. The fear is real, but the snake is not real. But the fear itself is caused by an unreal snake. Okay, so, and the snake vanishes the moment light is shown. So whenever there is knowledge, and if the ignorance is removed by way of light, if there is light, and ignorance, if there is knowledge, the fear will automatically go. This is an example which is, therefore, don't think that fear is caused only by real things. This is a classic example which is used. This is a very powerful example which is used in Nyaya Shastra. Okay, so this example was also there in tomorrow's class and all that. So since I've been thinking about examples in different fields, okay, for example, the counting 1, 2, 3, 4, 5, 6, 7, 8. How do you do that counting? Gauss asked this question. Gauss asked this question to his uncle or something. What is the point in having a number that cannot be counted? He says, physically, I cannot count 0. So that leads to a lot of problems. Let's not worry about that. Let's get back to this. So the problem number 7 is revisit problem 6 and recorrelate by removing the outlier. Work out the standard error and R square of the estimate based on only 4 points. Just do it. If somebody gets it, show it on this, and tomorrow the first 10 minutes we'll do this. Okay. Varshini, you got it?
Yes, sir. I used Excel.
So you didn't listen to my rope example.
I listened.
So you did both. So you're a genius, huh?
No, sir. I'm very bad at it.
Okay. All right. Tell me, what did you get?
A and B.
Wait. Give me some time to write it on the board. Just hang on, Varshini. Okay. So 0.4 is removed. Okay. So y equals
0.256.
0.256.
Yes, I think.
No.
1.971 x
1.
plus
Varshini, check your work. Y equal to 1.97
1
x plus.
2.985.
So if you are good engineers, what can you do further? If you're good engineers, what can you do further? You can very well imagine that it looks like it is 2x plus 3, but you are not knowing this because there is an error. Therefore, to adjust the error, I can recorrelate the line. Please note, what I am giving you now will not be found in any statistics book. It will not be found on the internet. So this is from my experience, and it is subjective. You may or may not agree. But as a true engineer, I would like to propose this. Okay, listen to what I'm saying. Okay, you can't find this in book. What I'm saying is, since it is 1.97x plus 2.95, and there are some errors in the measurement, I will say that all the errors in the measurements can be put on to the constant rather than the coefficient which multiplies the x. Therefore, that 1.97 seems to suggest that it is some y equal to 2x plus something, but that something is fraught with error. I believe that something is close to 3, but because there are measurements all over the place, it may not be close to 3. Therefore, I propose that all the error be in that constant rather than in the coefficient. So I will recorrelate as y is equal to 2x plus b dash, and I will try to get a new value of b dash, because if y equal to 2x plus b, it will be like y equal to T equal to ax plus b, that A can be related to the thermal conductivity in the heat flux in a heat transfer problem. So it is very unlikely that the thermal conductivity could be 1.9, blah, blah, whatever. Therefore, no, it can be also. So I assume that it shows there is some, that just like the torch light, there is a torch light. There is a light which tells me that it should be 2. So therefore, I will recorrelate as y dash equal to 2x plus something, and the 2.95 will come to something else. I'll recall. It'll have more error. It'll have a slight R square more. So be it. So what? Anyway, the world is full of errors. All right. So this is one way of approaching the problem if you're a true engineer. Okay. Now, let's stay with this. Now, staying with this, you please calculate the R square and please calculate the standard error. You will know that if you remove the outlier, there is a supreme increase in the performance of the correlation. Therefore, watch out for these outliers. Don't worry too much about the fellow who shouts in a meeting. Okay. So he or she may be a gas bag. You know what a gas bag is? Simply, if you open, only gas will be there. Nothing is coming out. So nothing else is there. No stuff. So always we should look at stuff. So in this case, there seems to be some problem. There's a problem with the thermocouple, or there's something else. This fellow who took the reading slept, or he went for chai, or something. So either you rework that data point or you just remove it. So if you keep on removing the data point, standard error is 0.2. Dharani, excellent, 2.233. Shreyan has done it. So 0.233 standard error, seems dramatic improvement in the standard error. Therefore, don't be just governed by theory, equations, and what you learned in JE or what you're learning in Scott. It doesn't matter. You're searching for the truth. So use the brain has infinite power. It is much more than what you know. Okay, it is much more than what you know. Okay, or it's much more than your knowledge of your knowledge. Okay, okay. So please use it creatively and solve this. Standard error is 0.23. It's very good. So we'll work it out tomorrow, and then I will actually draw it on the parity plot, show you what this outlier is all about, and then suppose there could be some strategies to pacify the outlier. How will you approach this problem? Let's do this. So there could be some variants of the least square that we'll do tomorrow and solve some more problems and proceed further. All right. Any doubts? I already lost some 10 people, 8 people. Chalo. So I came at 7:30 in the morning. It's me.
Sir, I just wanted to confirm something. So
Yes.
when we are formulating the summation of the least square, we have said that sigma I is a constant and we have taken it out from the denominator. Now, suppose the sigma I is depending on the ith experiment. Suppose.
Yeah, that is there. It is coming. Subhas, that is called weighted least squares. We are going to solve it in one of the later classes. Just hold on to your question.
Oh, okay.
What I have told you is OLS, ordinary least squares. That is WLS, weighted least square. We'll solve one problem, weighted least squares. Of course, this is an inverse course. We will do weighted least square. Good. Thank you for the question. We'll do it. Does it satisfy you?
Thank you. Yes, sir. Thank you.
All right. Chalo. I came at 7:30 in the morning. There was a slot. Some people might have been there. So 12:15, I'll have my lunch. All right. So thank you. So tomorrow, 10 o'clock. What happened? End meeting for all.